Do you know about the evolution of Earth? Let me tell you. Approximately 4.6 billion years ago, the solar system began to form from a massive cloud of gas and dust known as the solar nebula. This nebula collapsed under the force of gravity, creating a rotating disk of material. The Sun formed at the center of this disk, while the remaining matter coalesced into the planets, moons, asteroids, and comets. Among these nascent celestial bodies was the Earth, which began as a molten mass of rock and metal. During its early formation, Earth was bombarded by a constant stream of asteroids and planetesimals, a period of intense collisions that generated immense heat and kept the planet in a largely molten state. One of the most significant events in Earth's early history was the hypothesized collision with a Mars-sized body called Theia. This colossal impact not only altered Earth's rotation and axial tilt but also ejected a significant amount of debris into orbit, which eventually coalesced to form the Moon. The Moon's presence stabilized Earth's axial tilt, leading to more consistent climatic conditions over time. As Earth cooled, a thin crust began to solidify on its surface. Volcanic eruptions released gases such as carbon dioxide, water vapor, methane, and nitrogen, forming Earth's early atmosphere. At this stage, Earth's surface was inhospitable, marked by vast molten expanses and frequent volcanic activity. Water vapor from the atmosphere began to condense, leading to the formation of the first oceans. This marked a crucial turning point in Earth's history, as the presence of liquid water set the stage for the development of life. The earliest known eon in Earth's history is the Hadean, spanning from approximately 4.6 to 4.0 billion years ago. This era was characterized by extreme conditions, including intense heat, frequent asteroid impacts, and a predominantly molten surface. By the end of the Hadean, however, Earth's crust had stabilized to some extent, and the first oceans had formed. Following the Hadean, the Archean eon began around 4.0 billion years ago. During this time, Earth's surface continued to cool, and the first continental crust began to emerge. Life is believed to have originated during the Archean, with the earliest known evidence of microbial life dating back to approximately 3.5 billion years ago. These early life forms were likely simple, single-celled organisms, such as prokaryotes. Stromatolites, fossilized microbial mats, provide some of the earliest evidence of life on Earth. The atmosphere during the Archean was largely devoid of oxygen, dominated instead by gases such as methane and carbon dioxide. Early life forms relied on chemical reactions, such as chemosynthesis, to derive energy in this anaerobic environment. Around 2.5 billion years ago, the Archean gave way to the Proterozoic eon. This period marked significant changes in Earth's geology, atmosphere, and biosphere. One of the most transformative events of the Proterozoic was the Great Oxidation Event, which began around 2.4 billion years ago. During this time, photosynthetic organisms, such as cyanobacteria, began to produce oxygen as a byproduct of photosynthesis. Over time, this oxygen accumulated in the atmosphere, leading to profound changes in Earth's environment. The increase in atmospheric oxygen allowed for the development of more complex life forms and led to the formation of the ozone layer, which protected the surface from harmful ultraviolet radiation. The Proterozoic also saw the assembly and breakup of supercontinents, as tectonic activity shaped the planet's surface. One of the earliest known supercontinents, Rodinia, formed around 1.1 billion years ago, and began to break apart approximately 750 million years ago. This era also witnessed the first appearance of eukaryotic cells, which are more complex than prokaryotic cells and contain a nucleus and other organelles. The development of eukaryotes was a crucial step in the evolution of multicellular life. The end of the Proterozoic was marked by a series of global glaciations, collectively known as snowball Earth events. During these periods, much of the planet's surface was covered in ice, presenting significant challenges to life. Despite these harsh conditions, life persisted and diversified, setting the stage for the next major chapter in Earth's history. The Phanerozoic Eon began approximately 541 million years ago and continues to the present day. This eon is characterized by the presence of abundant fossil evidence, as life diversified and evolved into more complex forms. The Phanerozoic is divided into three major eras: the Paleozoic, Mesozoic, and Cenozoic. The Paleozoic era, spanning from 541 to 252 million years ago, was a time of dramatic biological and geological change. The Cambrian explosion, which occurred around 541 million years ago, marked a rapid diversification of life forms. During this period, most major animal phyla first appeared, and ecosystems became increasingly complex. The Paleozoic also saw the colonization of land by plants and animals, as well as the formation of extensive forests. The end of the Paleozoic was marked by the Permian-Triassic extinction event, the most severe mass extinction in Earth's history, which wiped out approximately 96% of marine species and 70% of terrestrial species. Following the Paleozoic, the Mesozoic era spanned from 252 to 66 million years ago. Often referred to as the Age of Reptiles, the Mesozoic was dominated by dinosaurs and other reptiles. This era also saw the evolution of early mammals and birds, as well as the diversification of flowering plants. The breakup of the supercontinent Pangaea began during the Mesozoic, leading to the formation of the continents as we know them today. The Mesozoic ended with the Cretaceous-Paleogene extinction event, approximately 66 million years ago, likely caused by an asteroid impact. This event led to the extinction of the non-avian dinosaurs and paved the way for the rise of mammals. The Cenozoic era, which began 66 million years ago and continues to the present day, is often referred to as the Age of Mammals. During this time, mammals diversified and became the dominant terrestrial animals. The Cenozoic also witnessed the evolution of primates, including the emergence of hominins, the group that includes modern humans. Significant climatic changes occurred during the Cenozoic, including the development of ice ages and the formation of polar ice caps. The most recent ice age, known as the Pleistocene, began around 2.6 million years ago, and ended approximately 11,700 years ago. During this period, large mammals such as mammoths and saber-toothed cats roamed the Earth, and early humans developed tools and adapted to diverse environments. Modern humans, Homo sapiens, first appeared around 300,000 years ago. Over time, humans developed complex societies, advanced technologies, and a profound ability to modify the environment. The Anthropocene, a proposed epoch that reflects the significant impact of human activity on Earth's ecosystems and geology, highlights the ongoing interplay between humanity and the planet. Today, Earth continues to evolve, shaped by natural processes and human influence. Tectonic activity drives the movement of continents, the formation of mountains, and the occurrence of earthquakes and volcanic eruptions. The climate system, influenced by both natural factors and human activities, plays a critical role in shaping ecosystems and biodiversity. As we look to the future, understanding Earth's history provides valuable insights into the challenges and opportunities that lie ahead. The story of Earth is one of constant change, resilience, and interconnectedness, a testament to the dynamic nature of our planet and the life it sustains.